This stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is to make the data bender even crazier. So if you're new here, we have been working on this project called the data bender, and it takes a video file and completely destroys it. It is amazing. And it destroys the video file by applying audio processors to video files. Crazy stuff, amazing things. Let's just dive into the thing that I want to do today. And Mage is here. Hey, what is up? Fair enough. I hope that you enjoyed this session and thanks for joining us. So let's just start the data bender and I can show you what it does. So it takes a video that looks like this. Just me playing the ukulele on a dark background. Nothing interesting going on there. But it turns that into these kinds of things by playing with the file with various audio effects. And what I'm interested in doing today is making this even crazier, if that's possible. So here's the setup. We have this function called databend, and it takes as arguments some things that are boring, like the name of the file that you want to produce. Fair enough. But what's much more interesting is the pixel format of the video file, the audio format that we are going to use when applying the audio effect to the video file, sample rate, and so on. And for each of these, you can provide just a pixel format to use, or you can provide different pixel formats for input and output. And I assume that if you do that, the results will be even crazier because you will be interpreting a pixel as something like RGB24 on the way in and then YUV 420p on the way out, for instance. And that's going to be crazy. And when I say on the way in and on the way out, I mean the way the data bender works is you provided an MP4 file. And we are going to convert from MP4 into this raw file that doesn't contain any headers, any metadata of any kind. It's just the information about each pixel, and it's not even compressed in any way. So it's just literally the information about each pixel on each frame. And we have to convert from MP4 into this raw format, and then in the raw format we can process this using audio effects. Then we have to convert back from raw into MP4, and that's what this output pixel format is all about. And we have this function that allows you to specify a separate output format. So when doing one data bend on one file, we do one conversion from MP4 into raw, apply an audio effect, and then one conversion from raw back into MP4. And when I'm saying MP4, it's just an example. This thing works with FFmpeg. It's going to work with any kind of video file you can imagine. Anyway, you can see that on the way in, we use this variable called pixel format. And on the way out, we use the output pixel format. So this function is already prepared to use different pixel formats on the way in and on the way out. But in the way that we use the function, we don't take advantage of this. So this is the definition of databend that takes this in account. But let's look at the way that databend is called right here, and you'll see that we provide a pixel format. We don't provide an output pixel format. That's what we are going to start doing today. And what I want to do is flip a coin, right? So I'm going to flip a coin, and in most situations, I will let the pixel format be consistent on inputs and outputs, because I think that the results of using different pixel formats will be really crazy. It may not even work depending on how FFmpeg decides to interpret the bits that make up the file. So I'm going to, in most cases, do what we are already doing. But in a few cases, I will want to just pick another one. And for the time being, we are just selecting out of a list randomly. But I can imagine that in the future, there may be more rules associated with the decision of pixel formats or audio formats, and particularly of audio filters. Because right now we just have audio filters using their default parameters. But in the future, I can imagine that we may want to have random parameters for the filters. So for instance, one of the filters is a compressor. It is using the default values for threshold, attack and release, and that sort of thing. But in the future, we may want to randomize this. So what I'm going to do is extract a function that does this selection of pixel format. I'm going to extract that into a function, and I'm going to call it twice, but not always. So you see what I mean. So I guess I'm going to call this function pixel format. And it is going to return this. It may look silly, right? I could just have a pixel formats array and then sample from the array multiple times. But I think that doing it this way will be better in the future. Maybe I'm falling into the trap of premature abstraction. We'll see. Anyway, so I call the pixel format function, and that is the same as what we had before, just written in a different way. Now comes the tricky part, where I'm going to say that the output pixel format, math random, so flipping a coin, and let's say that in 75% of the cases, we don't want to specify a special output pixel format. Let's unpack what I just wrote. So math random is a function that is going to return me a random number between 0 and 1. So when I say that this random number is less than 0.75, it means that 75% of the time we will get into this expression, the then expression, which is undefined. And the function definition says that if the output pixel format is undefined, then the default value is the pixel format. Otherwise, I call the function again, so I'll get a different output pixel format. And I think that this does what I wanted for the pixel format. So what I'm going to do is commit, and we are going to look at... So the reason why I committed is because I want to change this real quick. I want to say that this is less than 0, which never happens. Or better yet, I would just cut and paste like this. So I'm forcing the data bender to pick different pixel formats for input and output. The next thing I'm going to do is come here to the package JSON and change this from long back into short and restart the script. Now, with all of this, I am forcing two different pixel formats, and we'll see if FFmpeg wants to crash when you do that, or if the results look interesting at all. Let's just take a look. So I can delete all of these because they were previous runs. And it seems to be working. Yeah, it's still producing MP4 files. So let's take a look at them and see if they work at all. Oh no. Okay, I can see something. My The silhouette is still there. Okay, this is better. And mind you that everything else is still going, the audio filter and everything. It seems like in most cases it just damages the file too much. Ooh, this one is nice. This really makes me sad. It's just a black video. Nothing going on. Oh, this one is nice. Oh, an interesting consequence of this. Well, first of all, this one looks very nice. I like it a lot. Second of all, it has a consequence that I wasn't imagining, but of course it makes sense, which is it changes the length of the video, because if you pick as the input pixel format, a pixel format that represents pixels with 8 bytes, and then on the output, each pixel is represented with 24 bytes, then the video is going to become shorter. Oh, see? This one is only 1 second long. What? This is crazy cool. I mean, in the end it gets boring, but this is amazing. How did we get here? This is crazy. I love it. Well, anyway, so I guess in most cases, this really destroys the file. So perhaps what we want to do is to make this probability very low. Let's say that 90% of the time we are consistent in the pixel format input and output. And the other 10% will pick a different pixel format. Now let's move on to the audio format. Same story, but we'll see if the consequences of picking different ones is significant. And time permitting, we may get to packaging, which will be interesting for this project. And there is a chance that we'll get to packaging today, because I don't think that this thing we are doing is going to take a long time to finish. Well, famous last words, but I think it will be relatively quick. So same story, I did this, and now I'm going to change it like that. So I'm forcing different audio formats on the way in and on the way out. And yeah, I can just look at the results actually. Ooh. Yikes. This one is garbage. The other ones I'm okay with. I like this one. I don't like that one. Ooh. I really like this one. And this one too. You can see like one of me in yellow and then two of me and then four of me. That's crazy. That's super nice. Okay, and this one is garbage. So again, kind of makes sense for this to be a rare occurrence. 90% of the time we don't go there. Sample rates, I don't think will have such a big effect. And note that everything I'm doing has a cumulative effect, so it stands to reason that 1 out of the 10 data bands is going to get here, and 1 out of 10 of them is going to get here. So all of this is going to compound in ways that make it even less probable that you get something sensible on the way out. So perhaps what we should do is not have this as independent events. Yeah, or maybe raise this probability even further. Anyway, let's see what we have with different sample rates on the way in and on the way out. Garbage. Something. Nice. I'll take this. This one I like. It's like a nice background to something. Okay. And the video is super long too. Yeah, okay. I don't even have to watch the rest. I think that 90% chance of this happening, or I guess 10% chance of this happening is good enough, because it is a bit crazy. And hey, John is here. What's up? It is pop art, isn't it? Yeah, it was doing the Marilyn Monroe thing to me. What's the name of the person? Warhol? Andy Warhol, yeah. It was doing the Marilyn Monroe thing to me. Okay, let's continue. Let's see what happens when you get different audio channel counts on the way in and on the way out. It's already running. This is a short video and it's mostly noise. Interesting. And the second one seems to have a hard time finishing. What's going on? The logs are updated in real time. So it seems like the problem is in converting. Do we log before or after running the command? I think we log before running the command. That would make more sense. Yeah, we log. Oh no, we log after running the command. So there is a command running right now that is a slow command. Perhaps that's an audio filter that's slow. No, it is actually an error. Check this out. Interesting. But I don't see the error message. That's weird, isn't it? What command did we run? vclick. And what is the error? That's crazy, isn't it? It failed, but it didn't tell me why. Or at least I cannot see why. I wonder if this has to do with the declick stuff. Well, the good thing about the logs is that we can just copy and paste them into the command line. That was perhaps too quick. Well, but I guess it succeeded. And then let's paste this. And usually if ffmpeg is going to fail with something, it's going to fail right in the beginning because it's going to detect that there's something you cannot do, like a filter that is missing inputs or that kind of thing. So it's weird to me that it failed at the end or failed in the middle. It is also weird that this takes so long. Oh, well, it's not actually weird that it takes so long. In our experiments, the click was one of the slowest. So you know what we are gonna do? We are gonna take the click out of the list. Just like that. Yeah, that's kind of unfortunate, but it is what it is. We are taking it out of the list, so it is not gonna be so slow. And whatever error that happened... Oh, I know what error happened. We have a timeout. That's why ffmpeg didn't complain about anything. It was just going along with the thing, and it timed out. Yeah, that's what happened. Okay. I'm in peace now. It just timed out. Just timed out. But removing the click is a good move. Let's commit this. Well, let's commit this, which is removing the click from the list. But let's not commit that, because now we can return to what we were doing, which is to look at the results of having different channel counts on the input and output. Oh yeah, I went to a museum that had many pieces, original pieces by him. It's quite nice. I kind of like that kind of art. Good one. All right, let's see. If you have different channel counts, that's okay. Okay. Fair enough. We do want this to be kind of rare. I think we are reaching a point. So yeah, I do want the data bands to be crazy like they are, but I also don't want them to be super crazy all the time. I want some of the data bands to be like this, like really out of the box. Some of them I would like to be almost the original, but in a wacky way, playing with colors and whatnot. So I still think that this should be relatively rare. So 90% of the time we do pick the same channel count. But with all of this in the way, and the audio filter doesn't really have a notion of input and output, so we are done. And in fact, let's double check that we are done, but we should be done. I'm gonna compare the call to the definition. So output pixel format, output pixel format, audio format, output audio format, audio sample rate, output audio sample rate, audio channel count, output audio channel count, audio filter size, and output size. All right, so we are done with this. Now let's run this again, but this time we are taking in account these probabilities, so I'm not forcing any of the mismatches to occur. And let's see if we like the results. I think it already finished running, so we're looking at this. Let's run this again just in case. And this is too crazy. Not that I don't like this result, but I don't want this to be the norm. I don't want this to be what you get most of the time. And this is already too crazy. I kind of liked number 4. Yeah, but we're getting too many results that are pure garbage, and then one that doesn't change the input in any way. What happened to number 8? What filter did we apply? Set rate. Did we consider this interesting in the beginning? Yeah, we did. Huh. And by chance, we chose the same, this is audio format, sample format for input and output. And we chose the same pixel format for input and output. So yeah, we didn't really change the video in any way. That's boring. And this is garbage. Oh, and nothing again? What was number 10? Soft clip. Huh. Oh well. I guess we were trying to clip samples that were represented with an audio format that stores so many bits of information that soft clipping didn't do a lot. Maybe that's it. I don't know. In any case, I'm not too happy with the distribution of results. I think that it is too crazy, too often, and then it doesn't do anything in other cases. So I'm going to increase this number to like something like 97%. Should I increase this number, or should I make the events dependent on one another? Because one thing is for sure, if I am mismatching one of the parameters, then I should probably match the rest of them. Because if I mismatch 2 parameters, the chances of getting garbage are too high. But do I care about this? Because the events are so improbable anyway, because I don't think it matters. All right, so let's save this and look at the results. Okay, that's more like it. This is the kind of data band that I want to be more like the norm. Most results should be like this. And I can take this. And this is kind of nice because you can still see the movement. And this is my jam. This is what I love. How are we getting this? It's crazy. And this is similar to the previous one, but in color. This looks like a blur. This is garbage. Okay, I will take it. Ooh, not bad. Kind of nice. All right, I'm happier with this proportion of crazy stuff happening. And Bo is here. Hey, what's up? I'm doing well. Most bands look like copy protection. Some like VHS copy protection. Good point. How did that work? I don't really understand how VHS copy protection worked. But on Hacker News, I guess yesterday, the day before, there was this article about a format that it was a tape, and it was not very successful. I think it was just released in one country for 1 or 2 years. But then you would rent this tape, and it would have some technology inside that you could only play and pause, but you couldn't rewind. So you would rent a movie and you would be able to watch it once. And then you would have to return it to the store, and they would have a special machine to rewind the tape. That is crazy. I never heard of anything like that. And yeah, I don't really know how VHS copy protection works. Anyway, so I think I accomplished what I wanted to do in terms of mismatching input and outputs. The next thing we can do is for longer videos, because we were playing with shorter videos right now. But in the previous session, we worked on longer videos, and then we would cut 2 parts of the long video and then merge the 2 parts of the long video in a crazy way. So we could have more mismatches here if we mismatch the way we can mismatch the pixel format of one of the cuts with respect to the other cut, and that's probably going to have some crazy results as well. That could be fun to do. Yeah. Right. Let's spend some time working on longer videos. I'm gonna revert this. I am going to you know what I'm gonna do first? There's one thing that I dislike about the file names. They are just the numbers. I think that they should be appended to the original file name. So let's work on that. What I mean is instead of having just 1.mp4, I will have video long or video short, I guess in this case. Video short 1, for instance. Or maybe not even that. Because the problem is, if you run the program over and over and over and you want to play around with all the files, they're gonna have the same name. You can see 1.mp4 here and there. They're in different folders, but it stands to reason that maybe you would want to copy them all into the same folder. So perhaps what we should do is take the original name and append a random string to it, and this way you could dump all the files in the same folder. And we could put a timestamp on the log. Yeah. Let's do this thing, because it is kind of a management kind of thing, but it will be a quality of life thing for when people start using this for real. So let's see where we name the output file. It is right here. It is just the number of the bench and then the extension. But we do have access to the file name. We use it for the folder. Which is probably under the ffmpeg function. No, that cannot be it. Where do we have access to the file name? Output directory. Huh. Interesting. So it seems like we have this logic here, but we don't have a name for it. So we can either repeat this logic or we can extract this logic into another place. I think I'm going to repeat the logic. It is simpler. So where I say that, I can say something like this. And I lost the place here. There you go. And now we have input dash dash 1. But we don't want the number 1, we want a random string here. Oh, hang on, this is incorrect. This shouldn't read input, it should read video short 5. Why does it read input? Do we have a variable named input? I'm pretty sure we have a variable named input and we are shadowing this. Oh, we're not. Oh, and we already have a variable for the input extension. That's very odd. Why is this input instead of video short? Now it's crashing? Oh, right, this is the raw file. That's why it's called input1. Let's look at the logs to see why the thing is crashing. Yeah, that seems about right. Oh, but it has the examples thing. Okay, I get it. So we shouldn't be taking the input, we should be taking the path base name of the input. Still crashing. Ah, interesting. It seems like this crash doesn't have to do with the stuff we did, because it's complaining about the filter. So there is a chance of us running this again and getting it to work. And we got it to work. Interesting. So this is a problem we have to fix that has nothing to do with what we are doing. It just happened to happen now. Interesting. Crossover frequency should be greater than 0 and lower than half of sample rate. So the sample rate in this case is probably 4000, judging by the error message. And oh, okay, no, that is half the sample rate. So it seems like this sample rate may not play well with the compend filter. We can either get rid of the compend filter or we can get rid of this sample rate. I think I will get rid of this sample rate. Yeah, right. Okay. And we are getting video short, which is the name of the file, and then the number. But we don't want the number. We want a random string. We can get a random string by saying math random to string 36 slice 2. Of course, right? Let me show you. This gives me a random number between 0 and 1, like I mentioned before. If I take the toString of that, I get a string of that number. But the toString of a number accepts as argument the radix. Is that how you pronounce this? I think so. So you can say that you want this like in binary or in a base that has 3 numbers on it, or on base 8, or on base 16, or on base 32, or on base 36. Base 36 is using all the letters and numbers, but base 37 is not accepted. So that's why I had toString base 36. Then I don't want the 0 dot in the beginning because that's always the same. So I slice on the second character, and this gives me a random string every time. Note that it is not super consistent. The length of the string is different sometimes, but it is quick, it doesn't require any library. Good enough. So with this, I think we will have what I wanted, which is the name of the file and a random string at the end. What's up with that? Why are you taking the long file now? I don't know, but anyway, it is a random string at the end. Cool. Next, I will change the name of the log file from this Why am I extracting this variable? Because I will want to have the timestamp on the file name. But if I put the timestamp here, it will be different every time I call this function. So no, I want this log file to be defined outside so that it is defined once and for all. And I will not call this simply log. I will call this dash and the thing that the toISO string produces is a valid thing to put in a file name, isn't it? No, the columns are no good. Let's replace all columns with dashes. And that should be okay. But it's not. It is crashing. Why are you crashing now? Well, the funny thing is that it's gonna crash. And what it used to do when crashing was log, but I'm changing the log, so it's gonna crash while trying to log, and then it's not gonna log, is it? Yeah, it doesn't produce anything. Why is this a problem? Let's see. Well, we can be a bit more heavy-handed and replace more stuff, but what if I just put, for the time being, something like to do? Does that work? That does not work. So the problem is not that. That variable is not shadowing anything, so the problem is not that either. What could the problem be? If I do that, still crashing. If I reverse, it doesn't crash anymore. I guess we'll have to take this step by step. Even the simplest thing sometimes can break. Oh well. Let's extract a variable. Huh, interesting. Why is that crashing? Is the output directory not defined here? Well, it is defined. Why do you dislike this? Well, let's get back to a working stage and extract a variable here, as opposed to outside the function definition. Does that work? Okay, that works. Why do you not like when I take this outside? Because then it crashes again. Fail to data band. Check the logs for more information. Isn't this ironic? Interesting. What is failing is... Oh no, it's just the band. Why are you failing though? At least the variable extraction worked, because if that didn't work, then I would be really confused. The problem seems to be, it doesn't like when I define a variable outside the function body. Well, it must be because the output directory is changed somehow. Do we change the output directory somewhere? Oh, we do, here. But that shouldn't be an issue because this line appears above. So this is going to have run already. Yeah, all of this seems okay to me. Unless we try to log before we create the directory, that shouldn't be an issue either. What? Why? There is a hack that I think may work, but I really don't like it. So what I'm doing here is defining a variable and then saying, is the variable undefined? If so, then assign it this. And if the variable is defined, then never mind, don't assign anything to it. And I think that this is gonna work. No, not even that works. Oh man. What? This makes absolutely no sense. Let's revert to the known state again and... Ugh, yikes. Well, let's make the problem happen. The problem I explained, let's make it happen. We will have multiple log files. If I do this, then everything should work, and it does. But we will get one log file per output. Or not even that, one log file per command that we run. This is no way to live your life, but at least we have proved that the file names are okay. That's not the issue. And this is the kind of file name that we want to have. Let's finesse the file name and then try to worry about the real issue. Guys, I will call this data vendor log. Yeah, like that. Now we need to extract this name so that it doesn't change. How are we going to do that? I guess we are going to do that again, and we will try to get a meaningful error message somewhere, a stack trace somewhere that gives us any kind of clue as to what may be happening. So as we all know, at this point it's going to crash, but we are going to commit this because it is the code that we want to write. This is what is supposed to be working, and now we're going to chase the mystery. Why is it not working? Maybe you all have a clue. Let's see. Node was one is here. Hello, what's up? Decramping the filter crawls in the crash. Yeah, well, debugging the debugger. Okay, yeah, here we go. Here we go. All we have is fail to databand, check the logs for more information. There are no logs because we broke the log. Oh well. So I guess what I want to do is go there. And there is this result.success variable, and result is the result of calling databand. What does databand return? Oh, it just returns success and a time. Well, here's another approach. What happens if I just define this and I try to write to it? We should get something. We get nothing. Let's just console log this to see if this makes sense. We don't even get there. Oh, we don't even get there. Okay, that makes sense. This function is finally got it. This function is defined in the context of the databand function itself, which means that the last thing we are going to do is get there. So at this point, we will have already tried to do the databand. The lines that do the databand are above. So what we want to do is go to the top of the function and define the log file there. Which I guess kind of makes sense because we are manipulating file names over here, like the input extension thing is here. That should fix the problem. And it did fix the problem. Great. So here we have. But where is the log file? Where's the log file? Do we change the output directory? We do. So the definition of the log file needs to be below that. Now we are getting somewhere. Okay. Maybe this should include the file name as well. So let's put the file name here. We did something like that. Come on, here, yes. We did something like that here. So maybe we should extract this because we need it in two places. And we will extract this and we'll call it what? Input base name without extension. Perfect. And that variable we can define right in the beginning. Oh no, we have a syntax error. Why would that be? Here. There you go. And if I name this .log, I think it will make more sense. All right, so we have video long and then a timestamp and .log, and then we have a bunch of other file names. I'm happier. Should we have one log file per MP4 file? We could do that. No. This is good. I like the way it is. Do I want to keep playing around with file names and whatnot? Or do I want to proceed to something else? Let's see. I give it video long, I get a folder, I can copy and paste these files anywhere if I want. These file names are temporary, they go away. Yeah, this is perfect. This is perfect. Let's look at some of them to see if we like the proportion of craziness and whatnot. Ooh. Yeah, I think that we're in a good place. Awesome. Yeah, we debugged the debugger. Next, what do we want to do? We can play around with the long files, or we can think about packaging. I think I'm gonna go with packaging because it sounds like a low-hanging fruit. So here's what we are gonna do to package this guy. We are going to look at some other tool I have, some other tool I developed that does something similar to this. Not that. Open, add folder to workspace. Let's find another project I have that is a binary and that is packaged in pretty much the same way. So we do have course lore, but that is a big project. We may have more stuff than we need. Monitor is a good one. Yeah, I think I'm going to do that. I'm going to follow the setup from Monitor. And if you don't know Monitor, it is a very simple application, a command line application. You let it run on some computer somewhere that has access to the internet at all times, a server. And it is going to see if a bunch of websites are online. So let's say every 5 minutes, it's going to go to your website, check if it's online. And if it is not, it's going to send you an email. That's what this project does. And the way we package this project for distribution is using this file. So let's see what we have here. Oh, we already take care of packaging? Yeah, there you go. But it may be out of date. So let's do this. It was not out of date, was it? Yeah, if I change all occurrences of monitor to data bender, then yeah, it was not out of date. So let's just go over this and see if there is any changes we want to make. Well, there is kind of one change I want to make. And this is something that came up in course lore in some other projects using Cache, which is the tool we are going to use to package this. It's a tool that I developed for packaging Node.js applications. And the issue is that Ubuntu latest on GitHub Actions is using a version of Ubuntu that uses a glibc version that is incompatible with some distributions like Debian stable. It's a whole story, but anyway. Perhaps we want to change that, and if we do, then maybe using course lore will be a better reference, because I already fixed that there. But this does a lot more. Oh well, we'll clean it up. To begin with, anything that says course lore needs to say data bender. Second, we have to go over the whole thing and see what needs to change. Yeah, we are building index.mjs in there, so that sounds right. We don't need to change into this directory. We don't need to change into this directory. In fact, let's look for web. We don't need to test. We don't need to deploy. We do want to publish to npm. That can be kind of cute. We don't need to cd into that directory though. And we do want to publish a release. But we don't want to depend on test, because that is not something we run. Oh, hang on. Why did I take this out? We do have a notion of testing. Yeah, let's get back to course lore and web test and copy it again. Yeah, all of this looks okay, except of course for the for the web everywhere. We can remove that. Course lore is a bigger application. It has a web application, but it also has a mobile application. So that's why we have the web there. But here we don't need that. So build is going to have this strategy. Test. It's kind of silly, could be in a single line, but never mind that. Yeah, all right, looking good. Let's commit this. And let's push this, which should build. But let's also make a tag for this. Is the name available? Data bender. I should have checked this before. It is available. Awesome. So now you will see what you need to do to set up a package for distribution on npm if people want to say just npx data bender without having to install anything. And we will do we have a test stuff? Yeah. And you will also be able to download this from GitHub Actions. Let's go to liafac data bender settings, secrets, actions, and then there is this. Oh, it's already there. Repository secrets npm token. It's already there. So the only thing you have to do is set up this environment variable, or I guess secret, called npm token. You get that from your npm account, and then npm publish is going to work. So I think we have everything we need. There is one thing that may be missing. Do we have cache here? We do. Awesome. So npm version, and the version is 000 at this point. It is. So npm version, and let's start humble and do a patch release, which is going to be 001, and then git push tags to GitHub and git push origin main. So what that's gonna do is yeah, all right, create 2 runs, and this one should create a release, because this one is the tag. It should create a release, and it should create an npm package. So we will be able to go to npm data bender, and this will no longer be a 404 in a couple minutes if everything works. Hey. All right. And yeah, it was pop art again. John, in your compressors, do you low pass the signal controlling the compression, that is smoothed? Off topic, but okay, no low pass. High pass for the detection circuit is often used. Yeah, because you don't want the kicks to trigger the compressor, for instance. What is this packaging you are doing? Can you briefly explain? Yeah, sure. Maybe I should have explained it in more detail. So I have this project that you needed up to this point. You needed to download from GitHub. You needed to install Node.js. You needed to go to the command line and set everything up in order to be able to run it. But now you will have one binary. One thing, you can go to liafac data bender, go to releases in a couple minutes. It is almost finishing. So you'll be able to come here to releases and download a binary, an executable file. So on Windows, it will be a .exe. In macOS, it will be, well, it doesn't have an extension, but it will be a file you can run on the command line. And that executable has everything in it. It has everything you need. So you'll be able to just run that binary and it will do its thing. And here on npm, kind of same story. If you have Node installed and you don't want to go here and download stuff, if you have Node.js installed, you can say npx data bender and give it a file name, or give it all the command line options. So that's what I mean by packaging. I mean making it easy for people to download and run. I'm preparing the thing for distribution. And I developed a package called Cache that makes this relatively straightforward. And it seems like it failed, which is odd. Why did it fail? Package name too similar to existing package data bender. Try naming your package to liafac data bender and publishing it with npm publish. Oh, interesting. What does that do? Well, it is not a popular project. But I appreciate the fact that npm is trying to prevent confusion here. All right, I will take your suggestion and I will change the name of the package. Yes, sir. First time that I run into this, and I kind of like this kind of policy. It prevents issues that have happened in the past where you have a package with a similar name, but it actually deletes your hard drive or something. There's just one other thing I need to do to this package JSON to make this work. And I can go, for instance, to this package to copy the line I need, which is this. Oh, and another thing is I could be exporting stuff. Since I'm here, I'm going to do that as well. Yeah, so if you want to use this in Node.js, so you want to use this programmatically, so to speak, you can now, because I'm exporting this, and this file will have a function you can call from Node.js, so you don't have to go to the executable if you don't want. Perfect. Now npm version patch and git push origin tags and git push origin main. Oh, but interestingly enough, the publish release task ran, or job, I guess. The publish release job ran even though the publish npm failed, which means that you are able to go right now to this URL that should be in the description of this stream, go to the releases and download Databender and start playing with it. It's not a small download because it does contain FFmpeg, but it should work. Let's prove that it works. Let's go to this, which is the macOS version, and download it. And it's gonna be in my downloads folder, which I may not want to show online. Hang on. Let's do this while I manage this file. Go into my temporary folder. Because you never know what is in your downloads folder, or at least I never know. Okay, should be good. All right, you can see my screen again. And then I can go to tmp Databender. And you didn't see this part, but trust me, this is the file we just downloaded from GitHub. See, it is a somewhat big file. And you can call this, and it's going to take a little bit of time to extract the first time you run it. That's how Cache works, but here it is, data bending made easy. And it was relatively easy. Download and run. And then you have to provide it an input. So let's provide it an input. Maybe we can copy from code databender examples video short to here. So now we have this file here, databender video short, and it works. We don't see a lot of output on the command line while it's running, but it works. Here are the data bands that it is producing. All right, I'll take it. And you can do that too. You watching this. Go there, download it, play around with your files. And finally, let's check. This succeeded. It is green. So now we can go to npm at liafac data bender. We should see something there, and we do. Hey, the README is still crap, but never mind that. Don't look at the README. So with that, it means we can do something like go again, I guess, to the tmp data, not data, data bender, that. And I'm going to remove the file we downloaded from GitHub. I'm also going to remove the folder. So we only have the mp4 file, but I can say npx at liafac slash data bender of video short, and it is going to ask me to download. I will say yes, and this download is a kind of big. It's going to be 100 megabytes or more, or around 100 megabytes, I should say. But when this succeeds, it should start generating data bands, and it seems like it is generating data bands. We just don't see anything here on the output, but there you go. Here are some data bands. So if you have Node.js installed, really easy to use. If you want to go to GitHub and download that binary, really easy to use. I think that this accomplishes the data bending made easy promise that I make. All right, I'm trying to decide on a value for mine. It sounds like you are coding in a room by the SpaceX launchpad. Yeah, this is where I am. Trains are, and then I bumped into the desk, but trains are close by, which is great, except that I usually use the scooter, so I don't really care. Anyway, I now understand what packaging you mean. Yeah, of course. Quite embarrassing to show a download folder with lots of files ending in yeah, R2R. They're something related to piracy, probably, but I'm not even sure. No, but in my downloads folder, I do have things like documents from the bank and that kind of thing. Like my bank statement is in my downloads folder, and I don't want that to end up on the internet. Anyway, I think that we made a lot of progress. We played around with different inputs and output formats, and we packaged the thing for distribution, and it is really easy for you to go to GitHub and download this and start playing around with it. And I encourage you to do that, and let me know if you like the bands, and if you don't like the bands, what you don't like about them. Maybe they're too boring or too crazy, and then you can even send me the logs so we can see what FFmpeg did, and we can try and prevent that kind of thing from happening and making the data bands always more and more interesting. For the time being, thank you, John, Mage, Bo, Nod was one, and everyone else who is watching this. It is a pleasure to have you all here with me. It is always a lot of fun. I am looking forward to doing more streams, but probably not next week. It's gonna be a crazy week. I think I will try to stream at least once next week. We'll see. We'll see. But it is a lot of fun to do this, and I hope you are enjoying this data bender stuff. Perhaps next time we can do something else, maybe some audio programming or something like that. Anyway, thanks for being here with me today. I hope you have a great weekend. Bye. Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.